So in this lecture, we'll be talking about the notion of interrupts and exceptions and how do they affect a vanilla five-stage pipeline. So at a high level, an instruction that cause an exception or anything that causes an interrupt is actually an unscheduled event from the programmer's perspective, because the programmer hasn't planned for it. And this kind of disrupts the program flow or the instruction flow which are already there in the processor pipeline, right? So this interrupt or exception can be an external event. Imagine pressing a key through your keyboard, or an internal event, like getting a exception because of, let's say, divide by 0, right? And no matter what is the cause, we need to process it, we need to handle it. So there's a notion of interrupt handler. And even though these events are kind of rare, we have to make sure that we are handling it correctly, so that the programmer's view of the sequence of instructions that we are executing and the registers that are getting affected should not be hampered, right? So some of the causes of the interrupt or exception are in the form of asynchronous event or synchronous event. So I won't read this slide one by one, but what we will do is, so anything which is coming from the external world, we will term it as an interrupt, okay? And anything which is kind of coming from the program itself that we are currently executing, we will call it as exception, okay? So one of the simple example of an exception will be your page fault, if you're already aware of page fault, or maybe a system call, right? And for external event or interrupt, any IO interaction with your processor will be an interrupt. So if we need to understand from the program flow point of view how these two things are different, so in the interrupt, what happens is, let's say this is the instruction flow, and at this moment you got an interrupt. What the processor makes sure is it finishes the current instruction. So whatever is there in the pipeline, it makes sure it's done, okay, that it's kind of bitten back in the final stage of the pipeline, and then it calls the interrupt handler, right? And once the interrupt handler completes, it goes to the instruction which is after the instruction where you got the interrupt, right? But in case of exception, the current instruction which is there in the pipeline itself is the offending instruction, right? So that has to be handled, nothing from the outside world, in contrast to the interrupt, right? So which means the control has to pass to the handler immediately, right? That's the difference. In the case of interrupt, you have to make sure that the current instruction which is in execution is done. But in case of exception, the instruction itself is generating a fault or generating an exception, right? So that has to be handled. So you call the handler, and once the handler resolves it, you restart that instruction, because that was the instruction which was getting a fault or an exception, okay? So this is the high level difference between an interrupt and an exception. So when we say interrupt handler, it does the following things, right? And for making sure that the interrupt handling process is smooth, we will need some additional registers. So one of them is called EPC, or exception program counter, which stores the offending instruction, right? Whichever instruction is actually generating that particular exception, it will be stored in the EPC. And we have to make sure that the EPC is actually saved, right? The offending instruction is already saved in the EPC before we allow, let's say, interrupt, right? Otherwise, it may happen that we may get a nested interrupt. We need to make sure that no further interrupts are allowed until EPC is saved, right? Which means we should not allow any nested interrupt or any other interrupt before we are kind of done with this initial process of EPC. And once it is done, then we need to use another register called a status register that will indicate the cause of the interrupt, right? So whether it's a division by 0, whether it's a page fault, whether it's a system call, so that will be stored or encoded in a register called status register. So there is another way through which we can get the cause of a register, cause of the interrupt or exception is known as the vectored interrupt. So in that mechanism, the instruction itself tells you what exactly is the cause of this interrupt. Okay. So again, this is a pretty detailed slide that may help you in getting the entire picture clear. But if you look at from the processor side, whenever you get an interrupt or exception, you have to stop the offending instruction depending on whether it's interrupt or exception. In case of exception, you have to stop that instruction at that moment. You have to make sure that all the prior instructions are complete, right? So if you have instruction I1, I2, I3, and I3 causes an exception, you have to make sure I1 and I2 are kind of done in the pipeline, right? And you have to make sure all the rest of the instruction that follows I3 should not be fetched. So you have to kill it or flush it, right? And after that, you have to save the EPC, make sure no further interrupts are enabled, and jump to the address based on the content of the call register or depending on the vectored mode of handling interrupts, right? So in this way, what we are kind of trying to provide is we are trying to provide a precise state of information or the instruction flow, which means till the exception point, everything is done from the programmer's point of view. The programmer can actually see and read the registers. Okay. After the exception, till it is handled, nothing is fetched. Okay. So that is the precise state of the machine state, the precise machine state or precise processor state, right? So what the OS does, it looks at the cause of the exceptions and it actually trigger an interrupt handler, right? And depending on the cause of the exception or the interrupt, it will handle it. Once it is done, it will make sure that we are coming back to the usual mode, and that will be through this instruction called return from exception. So this is a indirect jump instruction which kind of now re-enable interrupt, because now you are kind of done with the current interrupt handling, and it restores the processor to the usual mode. So no longer the kernel is involved in this process. So now if we bring the notion of pipelining, the vanilla 5-stage pipeline, so you can have exception at any given stage. So for example, your PC address is not valid. That's why you are getting an exception in the fetch stage. Your opcode is illegal, the decode stage exception. You can get an overflow, right? In the execute stage, or again, your data address is kind of now not valid. So that's why you are getting an exception, right? Interrupt can happen anytime because it's asynchronous. It is not dependent on any pipeline stage, right? So what we have to do is the moment we know a particular interrupt or exception has come, we have to provide a precise state, as I have already mentioned, right? And to maintain the precise state, we need additional data path or signals that has to be taken care. Remember that it can happen that there are multiple simultaneous exceptions that can happen at different stages of the pipeline, right? So how will you handle it? So let's look at the exceptions first, because interrupt is anyway asynchronous. So in case of exceptions, whenever you get your exception, right, depending on which stage you are, you kind of start killing that particular stage. That means nothing will happen after that stage, right? And all the future instructions that follow that instruction will be also kind of flushed out. Nothing will be fetched, right? So it may happen that an instruction can actually lead to multiple exceptions. For a given PC, you can have multiple exceptions. You can both have PC address exception and also an illegal opcode. So in that case, the priority of the initial stages will be higher compared to the later stages, because once the PC address is kind of not valid, there's no point handling this illegal opcode, right? So this will be the priority of handling the exceptions, right? So depending on where you get the exception, you start killing that particular stage and the future instruction. And if it is an asynchronous interrupt, you kind of make sure that the current instruction is done, right? So that's the difference between an interrupt and exception. So once the current instruction is kind of in the write back stage, then only you can actually start calling the interrupt handler, right? So there is a new terminology that I'm using here, which is known as a commit point. So the commit point meaning the instruction is done and it's visible to the programmer, right? So the register contained and whatever that have been used by these instructions are now visible, right? So till that point, anything can happen because of the exceptions, right? But if an instruction has crossed this particular line, that means it's a valid instruction and that it can update the state of the registers and other things, right? So the key to understand here is you have to make sure that you have to hold the exception flags until the commit point, right? And as I mentioned, the exceptions which are actually coming in the earlier pipe stage, they override the later exceptions. Okay. And if we get an exception at the commit point, which is highly unlikely unless there is a pretty subtle case. So in that case, you have to do, there is nothing to be flushed out because already you are at the last stage. So you have to update your the cause register and EPC registers, kill all the future instructions and start calling the exception handler or PC handler into the fetch stage, right? So this is the overall picture about how interrupts and exceptions are handled in a typical 5-stage pipeline. With that, I will stop. Thank you.